In this problem from JEST 2020, we are given a Hamiltonian H. We are asked which of the following equations is correct. So to solve this question, we can make use of Hamilton's equations. Which are Q dot is equal to del H upon del P and P dot is equal to minus del H upon del Q. So if we use this equation, Q dot is equal to del H upon del P, we will get del H upon del P is P minus alpha Q 2 times P minus alpha Q divided by 2m, which is equal to P minus alpha Q upon m. So from here we get Q dot times m is equal to P minus alpha Q. This implies P is equal to m Q dot plus alpha Q. Therefore the first option is wrong because P is coming out to be m Q dot plus alpha Q. Now let us use, so from first equation we got A to be incorrect, option A is incorrect. Now let us use equation 2, which is P dot is equal to minus del H upon del Qi. This is equal to minus of 2 times P minus alpha Q divided by 2m times minus alpha this is equal to P minus alpha Q divided by m times alpha. Now P minus alpha Q is equal to m Q dot. Therefore if you substitute it here, we will get m Q dot times alpha divided by m. This is P dot. This implies P dot is equal to alpha Q dot. Now option B says alpha P dot is equal to Q dot, which implies P dot is equal to Q dot divided by alpha. But we just obtained that P dot is equal to alpha Q dot. Therefore option B is also incorrect. Now let us check if these two are correct or not, option C and D. To find if Q double dot is equal to 0 or not, we can make use of already derived equations. Here we have P is equal to m Q double dot plus alpha Q. Let us say this is equation number 1, and here we have P dot is equal to alpha Q dot. Let us say this is equation number 2. So if we take total time derivative of equation 1, then we will get P dot is equal to alpha Q dot plus m Q double dot. This is what we get if we take total time derivative of equation 1 in both sides. Now according to equation 2, P dot is equal to alpha Q dot. According to equation 2, P dot is equal to alpha Q dot. So let's say this is equation 3 and this is equation 4. Now for equation 4 and equation 3 both to satisfy, we should have m Q double dot is equal to 0, which means Q double dot is equal to 0. Therefore option C is the correct answer here. Now let us see why option D is incorrect. To check if option D is incorrect or not, we need to know how to convert Hamiltonian to Lagrangian. So the given Hamiltonian is H is equal to P minus alpha Q the whole square divided by 2m. Whenever we have P square by 2m in Hamiltonian, then in Lagrangian we will have 1 by 2 m Q dot square. And if something is subtracted from the Hamiltonian, then we will have, along with 1 by 2 m Q dot square, we will have another term is to be added. You have to multiply the function that is subtracted from the momentum with q dot. The function that is subtracted in the given Hamiltonian is alpha q, so we will multiply it with q dot and then we will add it to the 1 by 2 m q dot square, which is corresponding to p square by 2m. Then we will get the Lagrangian. The Lagrangian that we are given is 1 by 2 m q dot square minus alpha q q dot in the option D. So here it is actually plus, therefore this option is incorrect. The method we used here to convert Hamiltonian to Lagrangian is the faster method. Actually you have to use the equation L is equal to summation pi qi dot minus h, and you have to substitute pi here. In h also you have pi. You have to substitute pi in terms of q dot as a function of q dot, q and t. You have to substitute p here in terms of q dot, q and t. Then you will get the Lagrangian here as well. But for faster calculations you can use this. If there is p square by 2m in Hamiltonian, it will be 1 by 2 m q dot square in Lagrangian. If some function is subtracted from p, then there will be an extra term. You have to multiply f with q dot and add. If you found this answer helpful and if you are new here, then consider subscribing this channel for more videos like this. Thank you.